In today's lesson, I will discuss the multiple choice questions from the past paper in your book on page 228 and 229. Number 1. These statements below are about sound. The first statement, resonance occurs when two sound sources of the same frequencies are sounded together. That is a correct answer, because when resonance occurs, frequency should be the same. Number 2, sound cannot travel through vacuum. It is also a correct statement, because sound is a mechanical wave that has to travel through medium. The third one, the pitch of a sound depends on its amplitude. This is incorrect, because the pitch of a sound is dependent on the frequency. Amplitude will determine the loudness of a sound. So this is incorrect. The correct statements are 1 and 2. The answer is B. Number 2, a train sounds its whistle as it approaches and leaves a railroad crossing. An observer at the crossing measures a frequency of 450 Hz as the train approaches and a frequency of 400 Hz as the train leaves. The speed of sound is 340 meters per second. We want to find the speed of the train. Here we have two conditions, and we can make a comparison between the frequency that is heard by the observer when the train approaches the observer, and the frequency perceived by the observer when the train leaves the observer. When the train or the sound source is approaching the observer, then we should give negative sign to the velocity of the sound source. But when it leaves the observer, we have to give positive sign to the speed or the velocity of the sound source. While phi of the observer in this case is 0, because the observer is stationary. So we can use this equation, phi divided by phi minus Vs times the frequency of the source. When it leaves, phi over phi plus Vs multiplied by Fs. And when it approaches, when the train approaches the observer, the frequency is 450. When it leaves the observer, the frequency is 400 Hz. And we can cross phi out. So we have phi plus Vs, 340 plus Vs, divided by phi minus Vs, 340 minus Vs. 450 and 400, we can divide. This becomes 9, this becomes 8. So 9 multiplied by 340 minus Vs should be equal to 8 times 340 plus Vs. 9 times 340 minus 8 times 340 should be equal to 8 Vs plus 9 Vs. So we have 340 here equals 17 Vs, then Vs equals 20 meters per second. That is the speed of the train. So the answer is B. Number 3, the third overtone of an open-end tube A is the same as the fourth overtone of a closed-end tube B. So we have open-end tube air column, which we call A, and closed-end tube air column, which we call B. And we have the third overtone, F3. It is equal to 2V over the length of A. And for the closed-end tube, the fourth overtone will be F4. It is equal to 9V over 4 times the length of B. And it is stated that they are the same. The frequency of the third overtone and the fourth overtone is the same. So 2V over LA equals 9V over 4 multiplied by LB. LB is 21 centimeter. We can cross V out because V here is the speed of sound in air. It travels in air inside the air columns. So we can calculate the length of A, which is 8 times 21 divided by 9. It will be equal to 18.67 centimeters. And the answer is D. Number 4, the sound intensity level of 10 engines at a distance of 10 meters from the observer is 80 decibels. So we have 10 engines and 1 R1 is 10 meters and beta 1 is 80 decibels. Now we have 90 engines are added. So now M2 is equal to 10 engines plus 90 engines equals 100 engines. And all engines are sounded together at a distance of 100 meters. So that is R2, 100 meter. We want to find beta 2, the sound intensity level now. We have this equation, beta 2 equals beta 1 minus 20 times the log of R2 over R1 plus 10 times the log of N2 over N1. Beta 1 is 80, R2 is 100, R1 is 10, N2 is 100, N1 is 10. So we have beta 2 equals 80 minus 20 times the log of 10 is equal to 1 plus 10 times the log of 10 is also equal to 1. So we have 80 minus 20 plus 10, which is equal to 70 decibels. So the answer is C. Number 5, ambulance A is stationary, but the siren is whistling with the frequency of 1200 Hertz. So I have here ambulance A and its siren is whistling with the frequency of 1200 Hertz. Ambulance B is moving towards ambulance A with the speed of 10 meters per second and its siren is whistling with the frequency of 1155 Hertz. The speed of sound in air is 340 meters per second. We want to find the sound beats heard by the observer inside ambulance A. We know that an observer inside ambulance A will hear two frequencies. The first one is the siren of A, which is of frequency 1200 Hertz. And the other one is the frequency perceived by the observer due to this sound source. Because this sound source is approaching A, so the frequency heard by A will not be 1155 Hertz. Of course, it will be higher. It will be larger than this. And what we should find using the Doppler's equation is the frequency perceived by the observer in ambulance A. We use this F observer equals V over V minus Vs. This one should be also only V because V observer is 0 because ambulance A is stationary. And this Vs should be given negative sign because the sound source is approaching the observer. So V is equal to 340. V 340 minus Vs is 10 meters per second multiplied by Fs. Fs is 1155 Hertz. And this is the frequency of the sound source perceived by the observer. Remember that the observer inside ambulance A will hear two frequencies. The first one is this one, 1200 Hertz, and the other frequency is 1190 Hertz. So he will hear sound beats with the frequency of 1200 minus 1190 Hertz. It will be equal to 10 Hertz. So the answer, the frequency, the beats frequency will be 10 Hertz, C. Number 6, in an experiment using resonance tube, a tuning fork of frequency 400 Hertz is oscillated, frequency 400 Hertz, so that the second resonance will be heard when the length of air column is 63 centimeters, that is L2. We want to find the speed of sound in air at that time. We have this equation Ln equals to n minus 1 multiplied by 1/4 lambda. This is for a resonance tube experiment. We have now L2, which is 63. So this n will be 2. So 63 equals 2 times 2 minus 1 multiplied by 1/4 lambda. This is 4 minus 1 equals to 3. So 63 equals 3/4 lambda. So lambda will be equal to 63 divided by 3 over 4 or multiplied by 4 over 3. It is equal to 84 centimeters. And we have this equation V equals lambda multiplied by F. The lambda is what we calculated before, 84 centimeters, multiplied by the frequency, 400 Hertz. So V is equal to 33,600 in the unit of centimeter per second. This should be meter per second. So we want to find V in meter per second. It is 336 meter per second. The answer is E. Number 7. Miguel is waiting for Nathan standing beside the street. When Nathan comes, the speed of his motorbike is 20 meters per second, approaching Miguel, but he just passes by and rides his motorbike away from Miguel with the speed of 40 meters per second. So here is the situation. We have Miguel here. Nathan is approaching him with the speed of 20 meters per second, but he just passes by and leaves Miguel with the velocity of 40 meters per second. We want now to find the ratio between the frequency of sound heard by Miguel when Nathan is approaching him and the frequency when Nathan is riding away from him. So we have two frequency of observers. We have the first one is when Nathan is approaching Miguel. That's what we called FO1. And the other one, FO2, is when Nathan is leaving Miguel. So use the Doppler's equation, V over V minus Vs1 multiplied by Fs. Why negative? Because this is when the source of sound is approaching the observer. So Vs should be negative. We don't have VO because Miguel is stationary, standing beside the street. This should be given positive sign because this is when Nathan is leaving Miguel. So the source of sound is leaving the observer, so this should be given positive sign. Miguel is still stationary, so VO is 0. Yeah, we can cross Fs out and also V because V is the same, 320 meters per second. So all we have left now is V plus Vs2 divided by V minus Vs1. 320 plus 40 divided by 320 minus 20, it is equal to 360 over 300. So that will be 18 over 15. And the answer is B. Number 8. An air column of length 60 centimeters can produce harmonic frequencies of 650 Hz and 910 Hz. So the length is 60 centimeters and we can find the ratio between 650 and 910. We can find that the ratio is 5 to 7 because this is an odd number, and then we can conclude that this is a closed-end air column. And we know that so the first statement here is correct. And we know that F0, F1, F2, and F3 will be equal to 1 to 3 to 5 to 7. The ratio will be like this. So this 5 will belong to F2. So F2 is equal to 5V over 4L for a closed-end air column. So we know F2, which is equal to 650 Hertz. And we know the L, 60 centimeters. So 5V over 4 multiplied by 60 centimeters is equal to 650. And I can divide 650 with 5. So I have V, which is equal to 130 multiplied by 240 in the unit of centimeter per second. And that will be 312 in the unit of meter per second. So this second statement is also correct. The third one, we want to find the frequency of the fundamental note. Fundamental note is this F0, this F0, yeah? So if you want to find F0, this will be 1 over 5 multiplied by F2. F2 itself is 650. So F0 is equal to 1 over 5 multiplied by 650. And that will be 130 Hertz. So this statement is also correct. So we have 3 correct statements, 1, 2, and 3. Number 9, the mass of a load which gives tension to a string is initially y gram. So m1 is y here. And the speed of sound in the string is 1500 meter per second. I call that V1. When 70 grams is added to the load, so the load now m2 is y plus 70, the speed of sound in the string becomes 2000 meter per second. That will be a V2, 2000 meter per second. We want to find the value of y. We know this equation, V is equal to the square root of F over mu. So V1 over V2 is equal to the square root of F1 over F2. And then we are using the same string, so mu is the same, so we can cross it out. And then F is the tension. It will be given by the load, so it is equal to mass times G. So this is the square root of mass 1 times G over mass 2 times G, and we can cross G out. So V1, which is 1500, over V2, which is 2000 meter per second, should be equal to the square root of m1 is y and m2 is y plus 70. So it is 3 over 4 equals the square root of y over y plus 70. And I will square both sides. So I have 9 over 16 equals y over y plus 70. Then 16y will be equal to 9y plus 630. And I have here 7y, which is equal to 630. So y is equal to 90 grams. So the answer will be C. Number 10, in an open-end air column of length 30 centimeters, 3 nodes are formed. I want to draw the diagram like this. Open-end air column, the length is 30 centimeters. 3 nodes are formed. So this is the second overtone. In this situation, the note produced is in resonance. In resonance means that the frequency is the same with the note produced by a closed-end air column. This one, which 2 nodes are formed. So when 2 nodes are formed in a closed-end air column, that means this is the first overtone. So we want to find this L2, the length of the closed-end air column. We know that the frequency produced here and there is the same. So the second overtone here will be F2, 3V over 2L1. And the first overtone here will be 3V over 4L2. We can cross V out, 3V out, because V is the same. It is the speed of sound in air, because in an air column, it is air that vibrates. So 2L1, 2 times 30, will be equal to 4 times L2. And that's how we calculate L2, which is 15 centimeter. So the answer is E. Number 11. At a distance of 12 meters from an explosion, the sound intensity heard is I. So when R1 is 12 meters, I1 equals I. To be able to hear sound intensity of 9 over 4I, so I2 is 9 over 4I, a person should move as far as, we know that the relation between R and I is given by this. I1 over I2 equals R2 over R1 squared. I1 is equal to 1. 2I. I2 is 9/4 I. So I over 9/4 I equals R2 over 12 square. I can cross I out, so I have 1 over 9 over 4. So that will be 4 over 9. 4 over 9 equals R2 over 12 squared. And I can square root both sides. So I have 2/3, 2 over 3 equals R2 over 12. So 24 equals 3R2, so R2 is 8 meters. So the distance now should be 8 meters from the explosion. Before it was 12 meters, now it is 8 meters. So the person should move as far as 4 meters 4 meters towards the explosion, because now he should be closer. Before it was 12 meters, now it is 8 meters, so he should be closer to the explosion, so he should move 4 meters towards the explosion. The answer is E. Number 12, the frequency of sound produced by a string of a certain material can be higher when. Okay, in this case, we should use this equation. V equals the square root of F over mu, or V is equal to the square root of F over rho times A. And we should know that mu here is a constant. Mu is equal to M over L. So when we double the length, then the mass will be doubled too, so mu will stay the same. And we have to realize that F is proportional to V because we have this equation, F equals to V over lambda. Now, let's see the statements. The first statement, the length of the string is increased. Will the frequency increase? When the length of the string is increased, the mass will also increase. So mu still stays the same. So when mu stays the same, then when the tension stays the same, speed will not change. Then frequency will also be constant. So number 1 is incorrect. The mass per length of the string is smaller. So now we directly see the mu. When mu is smaller, then phi will be greater because it is inversely proportional to the square root of mu. Then when phi is greater, then frequency will be higher too. So the second statement is correct. Now the cross-section area. When the cross-section area, this A, is increased, then what happens to V? Because it is inversely proportional to the square root of area, then V will decrease when A is increased. When V decreases, then frequency will also be lower. It will decrease. So this is incorrect. The tension of the string is increased. Tension of the string is given by F. We can see that V is proportional to the square root of F. So when F is increased, V will also increase. Then frequency will also be higher. So this is correct. So the answers are 2 and 4. It will be option C. Number 13. The intensity level of the sound of an engine is 40 decibels. 40 decibels, the beta. Given the threshold sound intensity, this is I naught, 10 to the minus 12 watt per meter squared. We want to find the sound intensity of 5 identical engines. So what we have to find is the sound intensity of one engine. We can use this equation. Beta is equal to 10 times the log of I over I naught. The beta is 40 equals 10 times the log of I over I naught. 40 divided by 10 is 4. 4 is equal to the log of I over 10 to the minus 12. And 4 is the log of 10 to the power of 4. So 10 to the power of 4 will be equal to I over 10 to the minus 12. So I, the intensity, the sound intensity of one engine, will be 10 to the minus 8 watt per meter squared. So when we have 5 identical engines sounded together, then the intensity of the sound will be 5 times 10 to the minus 8 watt per meter squared. And that will be option D. Number 14. In the figure below, we have 3 points A, B, and C. A and B are sources of sound. The power of sound transmitted by A and B each is 1.8 watts and 0.2 watts respectively. What is the position of C so that C can receive the same sound intensity from A and B? So we can use this sentence to make an equation. I at A should be I at B. The sound intensity due to A should be equal to the sound intensity at C due to B. I is equal to power over area. So P over the surface area of a sphere, 4 pi RA squared, should be equal to the power due to B over the surface area of a sphere with radius RB, 4 pi RB squared. We can cross 4 pi out. So PA over RA. RA is the distance from C to point A, to the sound source A. RB is the distance from C to the sound source B. So PA is given 1.8 watts. I will say that RA is distance AC. So I have here 1.8 divided by AC squared should be equal to 0.2 watts, the power transmitted by B, divided by RB, because AB is 12 centimeters and this is AC, so CB will be 12 minus AC squared. I can divide 1.8 by 0.2 and that will give 9 over AC squared equals 1 over 12 minus AC squared, and I can square root both sides, so I have 3 over AC equals 1 over 12 minus AC. So I have AC should be equal to 3 times 12, 36, minus 3 times AC. For AC should be equal to 36, so AC should be equal to 9 centimeters. 9 centimeters is from A to C, because this is incorrect. 9 centimeters from B to the left. It should be 9 centimeters from A to the right, and that will be equal to 3 centimeters from B to the left. So the answer is option A. Number 15. Two identical strings with the same mass, length, and tension is oscillated with the frequency of 50 Hz. When the tension of one of the strings is added by 21%, so the tension of the first string is 100% F, while the tension of the second string will be 121% F because it is added by 21%. All the other quantities are the same. And then both strings are oscillated together. We want to find the frequency of the beats produced. Because the tensions are not the same, of course there will be a difference in frequency. Now what we should do is to find the frequency of string 2. So I can use this equation. F1, frequency 1 over frequency 2 equals the square root of tension 1 over tension 2. So that will be equal to the square root of F. This is 100% F equals F. This is 121% F. It will be equal to 1.21 F. So F1 is 50. F2 over F2 equals the square root of 1 over 1.21. It will give us 1 over 1.1. So F2 can be calculated. It will be 55 Hz. Now, there will be a difference of frequency here, which we call the beats frequency. It is 55 minus 50, or it will be equal to 5 Hz. That's the beats, the frequency of the beats produced. The answer is B. Okay, next week, this is the end of our discussion about sound waves. So next week, I will give you review questions of the second semester topics from the beginning of the semester for the preparation for final examination. So please do your best. Of course, if you have any question, you can always ask. I hope this video is useful for you. Thank you.